Hello students, I hope that you are good, well and fine. Today we will be seeing the NCERT miscellaneous exercise for chapter 1 class 12th relation and functions. We discussed every exercise and theory part. Now it's time to discussion for the NCERT miscellaneous exercises. Okay, so let's see the first question. Show that the function f from R to this set, what is this set? Set of all x from the real number such that x must be greater than -1 but strictly less than -1. In other words, if you try to see it in a what intervals, this will be open interval -1 to 1. Okay, I hope that it is clear. So my codomain is this codomain. So my codomain is this set, and domain is this set. Okay. So first of all, what I need to show is that this function fx is equals to x by 1 plus mod x is what? 1 1 as well as onto. Okay, let's see. So fx is equals to what? X by 1 plus x by 1 plus mod x. To show 1 1, we always start with f of x1 is equals to f of x2, and we try to show that x1 is equals to x2. If somehow we showed this, then this means that my function is 1 1. Okay, let's do. Now fx1 is equals to fx2. So this means what? This means is very clear that x1 1 plus x1 is equals to x2 1 plus mod of x2. Okay, now what? Just do some just do a cross multiplication. What you will get is x1. This will imply x1 plus x1 mod x2, which further equals to x2 plus x2 mod x1. Okay. Okay, from this what I can say is this. Now let's cases. So case 1 is what? Case 1 I am taking as x1 and x2 both positive. Okay, so this means what? This means is mod x1 is equals to x1 and mod x2 will be equals to just x2. Okay, now what? This equation will turn out to be x1 plus x1 x2, which is equals to x2 plus x2 x1. This will get cancelled. Okay, what you will left with just x1 is equals to x2. So we showed this part. Okay, what if case 2 occurs? So case 2 is x1 and x2 both negative. Okay, let's find out. So from this what it will become? So we know whenever if negative x is inside this modulus function, the output will be what? Minus of x1, and for mod x2 it will be minus of x2. This means my equation will be x1 minus x1 x2, which is equals to x2 minus x2 x1. If you solve it, what you will be getting is x1 is equals to x2. Okay, no problem, we still getting x1 is equals to x2. Okay, now what if the case 3 happens? Okay, so case 3, what it says. So first of all, let me clear the board for you. Okay, so can you think what case 3 I am talking about? So case 3 will be what if either of the x1 or x2 is negative. Suppose that case 3 is now if x1 is positive but x2 is my negative, then what? Then mod x1 will be just x1, but mod x2 will be what? Minus x2. Okay, now what will be my equation? My equation will be like minus x1 x2, which is equals to x2 plus x2 x1. Now just solve x1 minus x2, which is further equals to what? 2 times x1 x2. Okay, now what? Now as x2 is negative, okay, x2 is what? Negative. We know x2 is negative, okay, means negative, okay, and x1 is what? Positive. Positive. So from this what we can say? What we can say? Can we conclude anything? Just look at this equation. So positive multiply with negative number, positive number multiply negative number, what will be the answer? Is it positive or negative? Negative. Okay, negative. So this implies that x1 x2 will be what? x1 x2 will be some negative number. Yes, some negative number. This means this expression will be what? Negative. Okay, so this expression will be what? Negative. Okay, we agree. Now what? Now is this going to negative every time? If you consider, just consider x1 is equals to 100 and x2 just say what is x2 is minus 2, just say any number. Okay, okay, now just try to think. So I am clearing this. Okay, now what? From this we can easily say that it is negative. Okay, now x1 is positive, okay, no problem in that. x2 is negative, okay, just multiply by minus 1 both side. What we will get is minus x2 is greater than 0. Yes, we will get this. Yes, indeed. So now if you add this and this, what you will get is x1 plus minus x2, because x1 is a positive number and this minus x2 is also positive number, so the sum must be positive. Okay, so from this x1 minus x2 must be positive number. Okay, so this is what? My positive number. This is my positive number. So what I can say is that this equation is saying that positive is equals to negative. Can this happen? Can this happen? Positive equals to negative. Can this happen? Can this happen? This only can happen when both side must equals to be 0. Yes, so this only happens when both side must equals to be 0. So from this what I can say is that my both sides must equals to be 0. So from this I can say that x1 is equals to x2. Okay, and from this side what I can say is that x1 x2 is equals to 0, and from this x1 is equals to 0, and from this I can also say that x2 is also equals to 0. And the fourth case is the same when x2 is negative but x1 is negative but x2 is positive. Then you apply the same reasoning, applying the same reason, we can say what? We can say the same reason, we can say that x1 is equals to x2 and the x1 and x2 will be equals to what? 0. But this cannot happen. As you can see, what you can see, as we took our x1 must strictly less than 0 and greater than 1. So case 3 and case 4 won't occur. So this means only case 1 and case 2 will occur. So this implies that x1 must be equals to x2 in such cases. So we proved that if this is going to happen, then we will be getting x1 is equals to x2. Yes. So from this, what I conclude is my function is 1 1. Okay, I hope that it is clear to you that my function is 1 1. It is crystal clear. Now let's prove that it is on 2 also. So to prove on 2, so what is given to us? Fx is x by 1 plus mod x. Okay, and we know the modulus function can be break down into two parts. If x is positive or 0, you will get this x, and minus x when x is negative. Okay, just put fx is equals to y. What you will get? Y x upon 1 plus mod x. Now as you can see, this by cross multiplication, what you will get is y plus mod x times y is equals to x. Okay, now what? Now we will be getting two cases. If x is greater than equal to 0 and less than equal to 0, less than 0, then what we will be getting? If this happens, then mod x will be x. So we will be getting y plus y y times x is equals to x. Then you solve it, you will get x is equals to what? Say y minus 1 is equals to what? Not y minus 1, it will be what? 1 minus y is equals to y. This means x is equals to y by 1 minus y. Okay, and from this side, what you will get is y minus yx is equals to x. From this, what you get is, let's take this x plus yx. Now this implies y is equals to 1 plus y times x. Further, it implies that x is equals to y by 1 plus y. Okay, as we know, what we know, that x belongs to the domain, and domain is what? This R, set of all real numbers. Okay, so we have two equations. First, x is equals to y 1 minus y when x is greater than equal to 0. So this means this is also greater than equal to 0. Okay, and another one is x is equals to y by 1 plus y by 1 plus y when x is negative. When x is negative, x negative means this, the whole thing is also going to be negative. Okay, now what? Now just think of what value you can apply over here from real numbers, so that you can get this whole expression some non-negative real numbers. Okay, first of all, denominator cannot be equals to 0. So one restriction will be that y cannot equals to 1. Yes, y cannot equal to 1. Okay, now from this, as we know that y 1 minus y, what you can say is that if 1 minus y is greater than equal to 0, this means y is less than equal to 1. So this means this is my positive non-negative number, Okay, sorry, this cannot be 0 also. So this is my positive real number. So just by doing some cross multiplication, what I will be getting is this: y must be what? Positive real number. So y must be this positive real number, but cannot equals to 1, as well as this happens. So this means y must be less than 1. So this means y belongs to the interval, closed interval 0 to 1. Okay, now from here what you can say? Okay, what if just ignore this for a short period of time. So this happens when we assume that 1 minus y is greater than 0. What if we assume if 1 minus y is negative? Then what? Then cross multiplying, what we will get, just the sign gets changed. Then we will be getting y by the y must be negative. Okay, now what? From this what I can say is that y is greater than, sorry, yes, y is greater than 1. Okay, y is greater than 1, but from here what you can say is that y is less than equal to 0. Okay, now from this, can this happen that y is greater than 1 as well as y is less than equal to 0? This cannot happen. So this case cannot occur. Okay, so this cannot be possible. That's why we cannot take that 1 minus y is less than 0. Okay, now we will be seeing this case. Okay, for this means 0 is less than y 1 plus y. First of all, if 1 plus y is positive, okay, then I can get easily that 0 is less than y. From this what I can say, that 1 is greater than y and y is less than 0. Okay, this will be what? Y is greater than minus 1 and y is less than 0. Yes, so from this what I can easily say is that y is greater than equal to 0 but less than, y is greater than, strictly greater than minus 1 but less than equal to 0. Yes, what if 1 plus y is negative? Then what you will get? From this you will get that y is less than minus 1, and cross multiplying what you will get, as the denominator value is negative, the sign gets changed. You will get that 0 is less than y. Does this happen that y is positive but as well as y is negative? This cannot happen. So this case will not occur. Okay, so in total we concluded that we arrived at two cases. One is this, another is this, and from these cases what I will conclude is that y belongs to from here y belongs to closed interval 0 to 1, half open and half closed, and from here I conclude that it belongs to minus 1 to 0, closed at 0, open at minus 1. Now I will take the both of my answers as my set of the set of y values. So set of y values will be what? Y. Now in total you can see that y must be less than 1 but greater than minus 1. So this means my range set, this means range set will be what? All y belongs to the real number such that it is greater than 1 but less than, greater than -1 but less than 1. So as you can see, this is what? This is same as the codomain set. As you can see, set of all real numbers such that -1 to 1. It belongs to -1 to 1. Set of all real numbers such that all such real numbers which belongs to -1 to 1. Okay. I hope that it was very clear to you. So we showed that fx is equals to x 1 plus mod x 1 1 as well as what? On 2. Okay. I hope that it is clear to you. Every step, every reason behind it. Let's move to the next question. Next question says, what it says, show that the function f from R to R, as you can see over here, this is what set? The domain set, and this is what? The codomain set. Yes, codomain set. Now my function is defined like this. What we need to show? We need to show that it is injective. Can you recall what do we mean by injective? Injective means 1 1. Yes, 1 1 function. Okay. So in order to prove that a function, any given function is 1 1, we always start with what? F of x1 is equals to f of x2. Okay, we always start with, and through this we conclude that in the end x1 is equals to x2. If we will get succeed, then we say that this given function, any given function, is my what? Injective or 1 1 function. Okay, so let's do the proof. So start with fx1 is equals to fx2. My function is what? F of x is equals to x cube. Okay, my function is f of x is equals to x cube. Okay, now f of x1 will be what? X1 whole cube, and f of x2 will be what? X2 whole cube. Okay, from this what I can say is x1 cube minus x2 cube will be 0, and from this I know, what I know is aq minus bq is equals to a minus b, a square plus b square plus ab. This is the factored form for this expression. Okay, from this, so that's why I can rewrite it as like this: x1 square plus x2 whole square plus x1 x2. Okay, now we know that x1 and x2 both belongs to the real numbers, and the algebra of any two real numbers will also belongs to the real number. Okay, so from this is my real number, this whole output will be my real numbers, and we know a property that product of any two real number if equals to 0, this means either the first number is 0 or the second number is 0. Okay, so from this what I can say, either x1 minus x2 is equals to 0 or x1 square plus x2 whole square plus x1 x2 is equals to 0. Okay, if this happens, then this will imply that x1 is equals to x2. Okay, that was the thing we need to show. If this happens, then only we can say. What if this happens? Then what? Actually, in real numbers, this cannot be happening. Why? Let's see. This case cannot occur. This case cannot occur. Why? Let's see. So, x1 square plus x2 square plus x1 x2 is equals to 0. You are saying that, not you, actually I am saying that this is equals to 0. Okay, this is equals to, indeed this is equals to 0. Okay, now what? I am going to apply the quadratic formula. How? Let's see. So what we know that ax square plus bx plus c is equals to 0. Then x is equals to minus b plus minus root of b square minus 4ac by 2 times a. Yes. Taking a equals to 1, x as my x1 and b equals to x2, okay, and c is equals to x2 whole square. Okay, now just put these all variables and constant into our standard quadratic equation. Okay, let's put them. What you will get is quite simple. So a is 1, so a is 1 times x square, x I am taking as x1, so x1 square, plus b is x2 times x is x1, plus c is what? This. Okay, as you can see that it will become x1 square plus x2 whole square plus x1 x2, the same equation as before. Yes. Okay, now what? Now what we will do? Now we will find the value of x1. So x1 will be what? X1 will be minus b square is x2 square, okay, plus minus root b square is x2 square, okay, minus 4a is 1 times 1, c is x2 square, so this will be minus 4 x2 square and this will be minus 3x2 square, Now in denominator 2 times a is 1, just 2. So this means what you will get, the value of x1 is minus x2 whole square plus minus x2 root minus 3, and we know my root minus 3 will equals to root 3i, where I is what? Iota, or the imaginary number root minus I. So this means what? Minus x2 whole square plus minus root 3 x2 iota divided by 2. This x1 is will be my what? A complex number. When if this expression goes equals to 0. Okay, so if this becomes 0, then we will be having that x1 is equals to some complex number, but we are in real numbers. So that's why I said that x1 square plus x2 square plus x1 x2 cannot be equals to 0, because in order to have this expression equals to 0, my x1 and x2 both must belongs to the set of complex numbers. That means we are not talking about the real numbers, but we are in real numbers. So in real numbers this expression cannot occur, this equation cannot be true. So from this I can easily say that it is indeed what? There is only one case, okay, and from that case we concluded that x1 is equals to x2. Okay, I hope that it is very clear to you. Okay, so the main point or the crucial thing is to what is to get the idea of that this expression cannot be 0 when we are talking about real numbers. Okay, because if this is equals to 0, as you can see, by quadratic equation we can solve it for x1, or either equals to we can find the value for x2 as well, as both will be what belongs to complex number. Okay, so I hope that it is clear to you. So that's it from my side for this lecture. We will meet in the next lecture. So thank you for now. Thank you again.